What is up, my dudes? Welcome back to Quarantine and Code. So, today we're going to talk a little bit about the interactive mode. So, that's this bad boy over here on the right hand side. But before we jump into that, I want to talk about this program right here. So, we mentioned something called an IDE, and IDE is an acronym for Interactive Development Environment. So this is basically how we're interacting and developing um, for our program. For Snap, this whole kind of, you got the pieces on the side here combined with the palette and then the canvas. Uh, this is all an interactive development environment. So that's that on that. Next thing is we're going to focus on the right hand side here, so I'm going to make it a little bit bigger. So this thing on the right hand side is called a console, and console is not defined. A console is just something that allows us to interact with Python here. So so this is where we can make direct interaction. So for example, if I wanted to print, hey, it'll just print right here. So it'll run this line of code. This is the output of the code, and then it allows me to enter something else again. So it's uh, a direct line to communicate with Python. So what actually understands this code and knows to put the word hey? It's not the console. The console is just our way of interacting with this magical thing, and that magical thing is called an interpreter. And the interpreter just interprets code. It tries to convert Python into something that a computer can understand. A computer cannot understand the word print or these characters hey, but the interpreter turns this code into something that a computer can understand so that it knows, all right, put out the characters hey. So let's see if this works here. Oh, no. All right. So there, that's clear. Um, so the next thing is we're gonna show you guys some basic data types in Python, and to do that we need to use something called expressions or mathematical expressions here, and it's nothing crazy. It's just something like 1 plus 1. What do you think is going to output? It outputs 2. Um, so so there are a couple of different types in Python. So we have something like 1 to 111,254. These whole numbers are called ints because they're integers. They're whole numbers. And then we have something that's a little bit more specific. We have 3.14, 2.5, 0.0, 1.0. You'll notice that these are called floats because they have a floating decimal point inside of the number. And you'll notice that the number 1.0 and the number 1 they look different in the interpreter. For this, Python considers 1, just the number 1, to be an int, so it displays it differently than the number 1.0 because 1.0 is a float. So just to put that again, I write some notes over here. So 1 is an int and 1.0 is a float. So there you go. We can actually interact with different integers. So I can add integers together. 1.1 is equal to 2. 1.0 plus 1 is equal to 2.0. You'll notice that what is the type of this? That's right, it's a float. So when we try to add floats together, 1.5 plus 2, we get, if we try to add a float and an integer, we'll end up with a float. So we can do 2.5 plus 2.5, and we'll get 5.0. So we can add them together. We can also subtract. So 5 minus 2, this should give us 3. 5 minus 2.0, give us 3.0. So the same rule applies there about the floats. We can multiply things together. So 2 times, we need to use this little star or a little asterisk. So 2 times 5 will give us 10. 2 times 5.0. What do you think it's going to give us? That's right, 10.0. We can also do division here too. So let's take 10 divided by 5. And you notice that we used two integers, but we got a float back. So we got 2.0. So division always will return a float to us. Let's see what happens if we do 10 divided by 6. We'll get 1.66 all the way down here. So if you guys know math, you would think that this would be 1 and 2/3 and 2/3, but a computer has to represent the number and it can't go all the way to the end of the screen. So at some point it just cuts it off. So let me clear the screen here, and let's do something else. Let's do here's a good one. So let's do 5, and then we'll do 2 division symbols and 4. So this one we've never seen before. I'm gonna let you guys see what it does, and then we'll talk about it after. So this gives us the number 1. Okay, I'm going to try again, but with something different. So I'm going to do 9 double divider by 4. Okay, this one gives us 2. Interesting. So it's not the number left over. Seems like it's just the, because if it was the number left over, this would also be 1. So let's do one more. Let's do 13 divided by 4. Let's see if I do 14 double divided by 4. It gives us 3 again. So this double division will give us however many times 4, or the number on the right hand side, the number of times that it will go into the number on the left hand side. So how many times the number on the right hand side goes into the number on the left hand side. So if we remember it, it's like the number without the remainder. So if I had something like, if I did 12 divided by 4, I would expect I would get 3.0. But if I did 12 double divided by 4, I would get 3. So that's another thing to note, is that this gives us back an integer instead of a float, whereas regular division will give us a float. Next one is this percent sign. It's called a modulo. And this one is gonna, let's see what happens here. So we get 1 again, so it might be that it's just giving us the whole number in. Next one is 9 mod 4. Also gives us 1. What about 13 mod 4? Alright, seems like it's giving us 1 again. Let's see what happens if we just add 1 to it. We get 2. So the modulo will give us the remainder. So the double division gives us how many times it goes in. The modulo will give us the remainder of this number, the number on the right hand side, goes into it a certain number of times. What is the remainder after those times? What's the whole number remainder? Okay. So next data type that we have are, let me write that over here actually. So things that we can do with integer numbers are addition, subtraction, division, double division, and the percent sign. So next thing we have is we need to represent words, characters. So in Python, these are called strings. So we saw that when we were trying to print stuff out, we need to pass in a string. So ABC is just the string ABC. If I just try to type in ABC, it has a problem because the ABC here doesn't have a string around it, so it doesn't know what to do with this. Python doesn't know what to do with this. So we can do ABC with either one quote or two quotes, and they're both the same thing. So say ABC is a string, and a string just represents or stands for a string of characters together. So the string can be A, whoops, can be A, can be ABC, could be just empty, could be two quotes, still just empty. And you notice that even if I use the double quotes here, it ends up with single quotes. So what are some things I can do with strings? So we think, we can't use these math things multiple times, but we actually can. So let's say I did hello, and then I can actually use addition, world. So if I do this, I'll combine the two and get hello world. So this doesn't give me a space between them, so if I needed a space, I would have to do hello space and then world. What about if I try to do hello space and then add a number here, hello 1? We get a problem because this is a string, this is an integer. Python doesn't know what to do with those two. So that's how strings interact, and we can add them together, but we can also, and you guys will see this in the lab, we can't do addition, we can't do subtraction, but we can do multiplication with integers. So if I do hello and then 5, it'll print me hello, hello, hello 5 times. If I do hello times 6, it'll do that again. So we can interact with strings and integers not through addition but through multiplication, and we can see what happens if I try to multiply strings together. So we can't multiply a sequence by a non-integer. So what you guys are going to do is you're going to go through the lab, and you're going to try and see, you're going to try to guess what the value of the expression is going to be, and then you're going to run it over here in your console on the right hand side and see if your guess was the same as what it actually outputted, and then you'll submit that back. So it's very important that you guys try to do the guess first. I know you can just type it in and just see what the answer is and say, oh, I'm such a genius, I figured it out. But it'll help us figure out, does the thing that I think about, do I think that this is going to give me the right answer? And it'll tell you whether or not your thought on how this works is correct. So good luck. I will see you guys another day.